back to regular talks.
Yeah, I really enjoy seeing you all, but it's mainly that I have to renew my visa.
He's going to talk about ChatGPT, and he's already taking it away, so I'll let you keep going.
Thank you, Lewis. You've kind of stolen my first slide, which is a brief introduction. That's me, University of Adelaide. You'll recognise this building. Some of the best years of my life were spent in these buildings around here. I really love this place. It is nice to come back and see all of you, new and old faces. Nowadays, I spend my time at, depending on your ranking approach, one of the best universities in the world, which is very fun and has a very unique culture. So I want to quickly talk about that because I think it's fun and interesting to some people here. And then we're going to talk about why ChatGPT may or may not be the future of data science, hopefully leading some provocative debate for everyone in the room. So math school, School of Math. MIT Math is a very interesting and weird place. It's very closely connected in many ways with the computer science department, same as this place. Some notable things is Julia, which I know some people around here like, was invented at MIT. There is in fact the Julia Lab, which is an entire group dedicated to developing and pushing forward Julia. And pretty much all the courses at MIT are taught in Julia. So if there is any internal debate about languages around here, MIT is firm with that. Which means you run into Julia developers all the time. And it's like a religion. It really is. It's a little distressing. Other cool things that if you haven't heard about before, you should totally watch on YouTube is the MIT Integration Bee, which this is a photo of me actually at the Integration Bee. It's like a big event at MIT where a bunch of undergrads come together to compete on how fast they can integrate various equations. And it's this incredible like competition showcase. You like pick your undergrad that you want to win. You go in the running. You like place bets on them. And then the grand integrator gets a cat and like a math textbook as a victory prize. And it is truly a phenomena to watch and attend. Very stressful to watch undergrads integrate really fast. I am, however, not in the math department. I'm in a far weirder department called the Media Lab, which some of you may or may not have heard of. Who's heard of the Media Lab here? There. I hope you've heard of it for non-controversial reasons, and not because of bad things that may or may not have happened in the past. It is this very weird interdisciplinary hub, right? So there's lots of, everyone here at Adelaide Uni is siloed into different departments. AML does AML things, math does math things, bio does bio things, but we know that like biology uses data science and other skills. The Media Lab is a deliberately interdisciplinary group. These are a bunch of people that build robotic devices and cars, doing city planning, data science for cities. This is a friend of mine who does synthetic fabrics that respond to electricity and heat that can conform to different surfaces or parts of your body for various applications. There's an entire group who build robotic limbs and bodily augmentations, including exoskeletons. On their lab's board of directors is Tony Stark, like Iron Man, Robert Downey Jr., and are just an exceptionally fun and cool bunch of people. So these are all labs that are down the hall from me, which means I end up hanging out with synthetic biologists, other data scientists and mathematicians, mechanical engineer, electrical engineers, people whose entire PhDs is geometry, but physical. They fold sheets of metal into complex arrangements that can self-reconstruct. Just the most wonderful and weird people on the planet. And I think that culture of like connecting up across people is something that I think Adelaide Uni should do more, which is why I like to start presentations telling you all about this cool place. Also on that note, there is a relationship. Part of the reason about MIT is the Living Lab, which is this collaboration between South Australia and MIT. And I think we have some new funds potentially, which means if any of you want to visit MIT, we may or may not be able to put together some money to bring you over there. We'll probably save costs. You may stay in my spare bedroom, but I would love to have any of you come along and experience the fun of this place. Okay. I obviously have a cool little segment of MIT, but MIT itself has really embraced data science and AI and computation. Some rich person donated a lot of money to create a super department that sits above all the departments to force everyone in every discipline to do data science, AI, and computation. So if you are in biology, you almost will be guaranteed to take computation courses and do computational biology somewhere. Everyone at MIT has some kind of sophisticated data background, whether they did engineering or math or comp sci. And in every lab, you will find like extremely powerful computers doing weird things. It's very unlike other places. They've really embraced like the future, that data science is the future of every bit of science, from social science to biology to everything. This is not a research talk, this is not a job talk, but you may or may not be interested in what I'm doing with my PhD. It kind of centers around finding insights over private, decentralized data, using a mixture of kind of cryptographic primitives, decentralization stuff, incentive schemes, with a bunch of both simple data science stuff and some more complicated AI things. Kind of the whole theme of my PhD is that the future of computational social science and studying the human world is over distributed data. As we move into a world where people are less and less willing to pool data with large companies, and/or it becomes much harder to access. And how do we kind of build a stack of studying the world that doesn't require us to have access to large data sources? That's my research, not a job talk. What we're actually going to talk about today is what the future of data science looks like, which kind of touched on everyone here, whether it's as a student, like whether you're trying to write a dissertation, whether you're trying to teach students and ask them not to cheat, or what does cheating mean with these new tools, and kind of talk about what goes a bit beyond ChatGPT. To get us started, if you haven't heard the memo, ChatGPT is pretty popular. It is the fastest growing consumer app ever. If you didn't see this in the news, it took 2 months to hit 100 million users. TikTok, which I think we can all agree is a pretty addictive platform, took 9 months. And that was the new record holder as of, a year or two ago. ChatGPT has blown that out the water. The current usage statistics are eye-watering. And that drives partly that people who use it tend to use it a bunch once you get good at it. And pretty much everyone who hasn't heard of it, I came back to Adelaide, saw my mum for Mother's Day. I'm like, how are you using ChatGPT? She's like, ChatGPT what? Right? And I'm like, oh, let me introduce you to the gospel. So it is rapidly taking over the world. If you've missed the memo, very briefly, ChatGPT 4 is the large language model. That's the AI that does all the magic. That is giant, has many, many parameters, trained on a significant portion of the internet, although not all of it. They prefer quality of data over quantity. It has a chat interface, which is the thing ChatGPT that you use. It also has an API that you can directly access the large language model to do specific things. And this matters to what the actual future of this tool will actually look like. It's not just ChatGPT, it's more of an extension from it. I'm sure some of you have played with this. You've tried to put in your math homework from one of your courses into ChatGPT and see if it solves it. Who's done this? Either for teaching or... I'm not seeing a lot of students put their hands up, which is either you're very academically honest or concerned. But, yeah. You probably will have noticed that it's really bad at solving questions, right? You put in your assignment questions and it doesn't do that well. Sometimes it does. Sometimes it will just hallucinate and make up a nonsense answer that is totally false. And some students may be inclined to take this nonsense answer, put it directly into their assignment, and upload it. And you'll be like, this doesn't make any sense. And you've clearly cheated using ChatGPT. And that is because these large language models are trained on large corpuses of text, doesn't include check, interestingly, but have memorized how math kind of works such they can hallucinate it and impersonate it without really doing it, right? They're really not good at data science for a bunch of reasons, because these large language models can't parse data themselves, right? You can paste in a bit of data, but what's going to do, add up numbers? That's not how these things actually work. They're more about understanding text. Students are clearly already using these, as I'm sure you've discovered. Coincidentally, Google's Bard got released several days ago. It is much better at doing math, in particular, solving equations and understanding text. This is implicit, not programmatic. They haven't made it deliberately better at doing math. They just happened to train it on a particular set of data that ended up with it being better at doing math. So it's kind of a coincidence from the training, not a particularly deliberate task by them. I still wouldn't trust it. It still hallucinates a bunch. But we can do much better. So these large language models are really good at writing code. That they are spectacular at. Can sometimes be a bit dodgy, can still hallucinate occasionally, but generally if you give it a task, it will write code to achieve that task. If you give it the right piece of text, for example, the head of a data file, you ask it to write tasks to calculate something, it will generally, faithfully write particular code that can do things. So this is where I would like to call Peter. Well, Peter's got his laptop, but come up here. Peter is doing an internship through the Living Lab, which is a thing we've been putting together for undergrads, which pretty much anyone can do. It is like a summer research scholarship where you kind of get time to have fun and learn things and play with stuff. But in true MIT Media Lab fashion, it's very much focused on figuring out what the future is instead of writing a really good research paper, which is kind of how a bit of our incentives are different. So I'll let Peter introduce Dr. Almonds.
All right, hi everyone. So this is Dr. Almonds. It's a language model nailing data science, and I think that's pretty nuts. Thank you. All right, so it's asking me to upload my data file, and I don't really want to disobey it, so I'll just tell me what it says. Do what it says. All right, so I've uploaded data, and it's giving me the head of the file. So it's the first few rows, the variable names, and what it's asking me is to give a context. So remember, this is a language model, so it takes language as an input and then gives language as an output. And it's really good at doing that. You can interpret the variables by themselves, but it's better if you can give them some descriptions of what they are. So I already pre-filled some of the context. So you have to look at me. There we go. So the data was collected by creating a website where participants are shown a picture of a candy, and then they pick which one they prefer, which one tastes better. So it's got the competitor name. That's the name of the candy, which is pretty self-explanatory. And then it's got peanutty almondy variable, which just says whether the candy contains peanuts or almonds. It's got sugar percent, which is the percentile of the sugar in that candy, and the win percentage. So that's how many times people said, yeah, this is the candy I like. All right, so let's submit that to Dr. Almonds. And now it's processing. So one of the problems you might notice with these language models, it takes a while for them to process data. So while it's thinking, you can always ask me questions as we go along. There will be a couple of times where it's doing this, but okay, here we go. So previously, all you saw wasn't a language model. It was all just stuff that I generated, except for Dr. Almonds himself. That was made using OpenAI's DALL-E model, right? Because I'm not that good at animating, right? But this part of it here is the first bit of generated text. So what it does is it gives us some description of the data. And then what's interesting to me is that it gives us this suggestion. So to analyze the data, we can use a regression model, more specifically a multiple linear regression model, right? So I didn't tell it to do that. It just looked at the data and said, that would be a really good thing to do. Okay, but before we get to that, let's start off with something a bit more simple. So I want to know, what is the most popular candy and does it contain nuts? All right, so I think that's a pretty standard thing to ask when you see this data. What is a good candy? Hopefully Dr. Almonds doesn't get too offended if it doesn't contain nuts.
How did you come up with the name Dr. Almonds?
Oh, well, I need to get data science in there, language model, and so it was kind of like one of those puzzles where all the letters are mixed up, and I just had to find almonds in there somehow.
Did you use ChatGPT to make the name Dr. Almonds?
Okay, I did use ChatGPT to try to come up with it, but it wasn't giving me good things, so that was all my own work. All right, and so that's pretty good. It gave me nuts. It's generated some code, and what the cool thing is that not only can it generate code, I've also made it so it can run the code. And it gives me the output. The most popular candy is Reese's Peanut Butter Cup, and it contains nuts. Happy days.
So this is like a wrapper. You take a task, and instead of giving the task to the language model, you say, please write code to achieve this task. It does that, and then you run the code.
That's right. It runs the code, it gives the output, and also gives an interpretation. So in this case, the interpretation isn't really that useful because you can already see what it does. But in certain scenarios, it can be better. And that's the next thing I'm going to do is see if it can actually do a bit more statistics and build this linear regression model. So that's the next question. I'm going to ask it to fit a multiple linear regression model with win percentage as the response and provide a summary. Then I also want to ask it, does containing nuts increase the win percentage, and is it a significant predictor? So this is your book standard first year stats assignment question. All right, so if it succeeds, then we can confirm that you can cheat in first year at least.
I think we confirmed that long ago. And this is all happening on the fly. You've not hard coded any of this. This is all
yeah. So this is every time I write a prompt, I do an API call to OpenAI. So I'm using GPT 3.5 model. So the code with GPT 3.5 is a bit worse than GPT 4, but it's a lot faster. And I don't want this talk to just be us waiting for Dr. Almond to come up with an answer. So we're using 3.5 for now.
Well, it's worth noting that a lot of these APIs are getting much faster. GPT-4 is really large and really slow, but some of the really good, the Palm 2 model that just came out is like as fast as 3.5 and mostly as performant as GPT-4. But that's news as of the last like 5 days. So
yeah, so GPT 3.5 was released at the start of the year, but by artificial intelligence standard, that's like old tech. Nobody cares about that anymore. All right, so it's given a response again. It's got the Python code. And this is the interesting part. It's got the output and it's got the whole model summary. Okay, but it's got all these numbers. They're pretty scary, at least for me. I don't know what half of them mean. But over here, I've got the interpretation, right? So I gave it a specific question, and that's about the nuts, whether nuts make the candy better. And so over here, it says the coefficient of peanut almondy is 15.3, indicating that containing nuts increases the win percentage. So that's pretty good. It also tells me that the model explains 20.3% of the variance. And so, there's no 20.3 in any of the output, but it found the R-squared value, so it's 0.203, and interpreted that to say that 20.3% of the variance is explained with the model. That's cool stuff. But one more thing I want to ask it is, can it create plots? So now that we've got this model, is it any good? And so I'm going to use some diagnostic plots. I've asked it to do a fitted values versus residuals plot, and also a QQ plot to test for normality. So again, this is just the things I've learned in statistics. And maybe I know the maths behind it, but I don't really know how to do any of the coding. And that's what these large language models can really help me with. And you might be thinking, well, it's a language model, so it can write text, but how does it do plots? How can it make a plot? And that's the whole point of integrating it with the Python code. So the Python code can make the plots. And now we just have to run the code, and then we can display them and make our own interpretation.
how have you built this web app?
So this web app it's written in Python. It's using Flask. And so I had to use Python, HTML, and JavaScript to make it. And none of these I knew how to do before starting this internship. And I used ChatGPT very heavily to make it. So it's kind of meta how I used AI to make the AI. All right, so it's got code again, and there we go. It's got these plots. So we can see that we see homoscedasticity, so assumption of variance is met. We see linear assumption is met. And from the normal QQ plot, the residuals are normally distributed. So good job.
This man did his stats courses very well.
Yeah, thank you.
So I know the answer to this because I saw you doing it, but just for the other people, multiple linear regression is very simple. What if I wanted a Poisson regression?
So Poisson regression, you can actually do it because it's seen enough examples on the internet which means it knows the code to make a regression. And so it's not a plus on this time, but I'm using a logistic regression. And so I want to see, I'm going to do it the other way around. So if we've got the win percentage and we want to make a classification whether or not it's got nuts in it. And so that this model is a bit more complicated, right? So it's not none of this first year stuff anymore. We're going to serious business. I only learned about this, a couple of weeks ago. So really high level stuff. And let's see if ChatGPT can handle it.
So is this a next assignment?
Yeah.
He may have shown me my own assignment in a prac.
Yeah.
With Dr. Arnold's.
Can it tell you when the model's misspecified for the problem?
So that's one of the things that it's not as good at. So I'll quickly go through this. So, oh no. So okay, that's actually quite interesting. I'll be honest that I did choose these questions and I ran them before, like I was running them yesterday, I was running them this morning and they were working. I chose prompts that I knew it would be able to do. And just before coming here, it was working, but now there's an error. So yeah, and it gives you the error as well. It's just, so you can afterwards use that to improve your prompt to get the correct output, because it does know how to do all of this stuff, but it sometimes can make a mistake. And so that's why everyone in this room can be calm, that you're not going to be replaced by an anthropomorphic almond, but you'll still have your job by the end of today. So what it can do is it's really good at generating code, but you still need a human in the loop. You still need someone to interpret the output. You still need someone to tell it what to do. It's not as good as telling you which model to use for the data, but if you know what you want it to do, it's very good at making the code. And there's another admission I have to make, which is a bit related, that really, you might have noticed that in almonds, so a language model nailing data science, I've skipped out the O. What the O stands for is occasionally. A language model occasionally nailing data science. But at the end of the day, I think that everyone in this room can and should be using artificial intelligence. So it really accelerates the work that a data scientist can do. And for someone who has no knowledge of data science, it really enables them to do more analysis with their data, even without any coding experience. And I think that's the real benefit of having an AI like Dr. Almond's. So thank you.
Now, 2 seconds briefly as I refigure out how on earth Windows and Zoom work. I swear I know what I'm doing. Cool. I think this was a fantastic. I love that it's named Dr. Almonds, and that before I saw any demo of the actual app working, I saw this logo and I was like, I know this is going to turn out well, right? As soon as I saw that logo. So I think that is an excellent demo of what the future of these kinds of applications look like. It's not just using ChatGPT, but something built on top of it to do interesting things. Let's keep talking. Do you know how we know this is a really good idea? Is that ChatGPT has already started stealing Peter's idea, whether or not they realize it. So for one, they've started allowing you to execute code within the ChatGPT interface, which is certainly not the same as what Peter's done. Peter loads in the data that you upload. It asks specifically for context in case it doesn't know it. It ensures that there's always like an interpretation and an explanation of what's going on. ChatGPT, as you know, is like the Wild West, and it will do whatever you tell it to do. And if a student doesn't know to ask for a certain, context being provided, the model may just hallucinate and make up a bunch of stuff. And kind of the danger of this is when you do assignments, you use pretty standard data that exists on the internet, which means ChatGPT has been trained on it and it knows about this data. So students get used to the AI just having a sense of like what the context of variables will mean. And then you try and take it out of domain, like a unique new data set, it breaks catastrophically. And students may be very unprepared for when the model doesn't just implicitly know things. It also has, from more of a math side, the Wolfram plugin, which I think they've made publicly available now. I'm not sure if they have yet. It's very fun to play with. It is like surprisingly good at taking whatever random math nonsense you put into it, calling Wolfram Alpha and solving it. And this doesn't just hallucinate, essentially LaTeX code that it thinks might be correct. It's actually symbolically solving it and then returning those answers to your chat interface, meaning it's actually correct. Bard has a similar thing called Bard tools, which is similar to the plugins. These work fundamentally differently similar to what Peter's done, but fundamentally different to just how normal ChatGPT work. This is a minor flex. One of the fun things about being in Boston is it's where Wolfram, like Stephen Wolfram, is from. There's also a bunch of other people. So this is Sam Altman, the CEO of OpenAI. That's Lex Friedman interviewing Stephen Wolfram at the event we hosted as part of the Media Lab the other day, which was very cool. So the way the ChatGPT plugin works, which I think is interesting to think about, is you put in your text, and before it is passed into the large language model for output and interpretation, a second large language model looks over that and says, does this query need a plugin? It says, yes, it needs Wolfram Alpha. Another large language model call comes in and says, take this query and convert it into an API call for Wolfram Alpha in the Wolfram symbolic language, which I don't think I have a picture of, but it will write it out in the weird Wolfram Alpha code that you might have seen. It knows how to write that. And so it will just make an API call and then takes the response to that API call, essentially pastes it into that ChatGPT window, into the context window, and then ChatGPT will know how to output on that. Funnily enough, this is something that Sam talked about at this event, is all these new plugins, the way they do the safety checks on those plugins is you write in text how the API should work, and have a large language model run your API. The entire OpenAI infrastructure of ChatGPT is language models looking at language models looking at language models. It's kind of terrifying. All safety checks are done with large language models. The way that they get ChatGPT to behave and not have anything malicious is they tell it so. They're like, don't be naughty, don't be mean, don't be racist. And that is the current state of the art in safety guarantees for AIs that are taking over the world. And I think they should terrify us a little bit. There are things that move kind of far beyond these simple chat interfaces. So they are prompt response models, where you ask it to do a thing, it does a thing. You say, what's the interpretation of this? It gives you the interpretation. What Peter's done is a step beyond that, where it frameworks how these tools will work. Who's heard of an auto GPT or a baby AGI here? Anyone? Yeah. If you read Hacker News enough or surf Reddit, you'll eventually run into these things. Essentially, some hackers were like, cool, we've got big AIs. Let's immediately try and invent artificial general intelligence and make it do bad things. You've got to trust the hacker community to have bad ideas. And so the idea is you give it a task in the same way you would ChatGPT, right? Complete my data science assignment. And it just has a recursive loop that keeps looping and keeps making API calls to GPT-4 to complete the overarching task. And it has kind of a complicated infrastructure where it does this prompt engineering like Peter's done to complete the task. And it can save information into a memory. It can query, you can do task planning and task execution with AI. You can also call code and do other things, make web queries, search the web. And so the example people would use is find the emails of everyone at a Fortune 500 company and send them an email telling them about my great new data science tool. And it will go, you prompt engineer, what are the tasks needed to complete this? It will list out the tasks. First step, search on LinkedIn for Fortune 500 company CEO. And then, action, call open web browser. And it will open the web browser, it will perform the task. And it will repeat this step. It will keep asking itself, what is the next thing I need to do? What is the next thing I need to do? Until it believes it has completed the original query, right? It's essentially automatic ChatGPT with a while loop. These things are terrifying. Obviously, about 3 days after it was released, someone said, destroy the world as its task and saw how far it could get. People have tried to say, make as much money as possible, starting with $1,000, and they as a human will do whatever the AI says to make money. These are incredible, LinkedIn influencer posts. If you want to make it in the game of being an influencer, I feel like now's the moment to use GPT. it's, some people are worried about this as like a dangerous thing for like how AI can affect our world. But I think this is actually the future of what most tools will look like to achieve tasks. So a combination of looping agents and executing code using the Wolfram symbolic solvers. There's a great paper that came out called Reflection that's gotten a bunch of citations, and it was written exclusively by undergrads. And the paper was, they put things into GPT-4, they asked it to do a code, and they said, do you think this is correct? If not, improve it. And they take whatever the output of that second response was. And if you look across all the benchmarks that computer scientists use, if you just ask ChatGPT or GPT-4 to reflect and improve, it does markedly better, like 15% better across every benchmark there is. And it was just a bunch of people with a crazy idea to try and do it. And so you can ask it to think and you can ask it to reflect, and it will self-improve its responses to get better and more accurate. A feature that we can add to fix the code execution bug is if you get an error, ask it, was this, if you saw an error, how could you make this better to avoid the error? And you're like, I don't know, maybe it'll fix. Do you think it would fix? I think it would. It's like a remarkably good tool. You've already seen it generate plots. It can execute code. It can call Wolfram. It can do web searches. It will still be a prompt that someone gives. You still give it a task. It will loop through, do all these things to try and faithfully execute your task. But there's still a human in the loop making interpretations, doing these things. You still need to understand the context for this to work. And so what it essentially is Starter on steroids, right? We've invented an application which does all of the hard work for you of doing data science. It takes in the data, it figures out how to run regressions, it can solve everything, but 1,000 times more powerful and focused on the intended goal that you actually want. Which I guess gets to what I actually wanted out of this conversation, which is now that we've invented a tool that essentially takes everything we do in the classroom, which is we give you a task, solve the task. We're training our students to do exactly what this does. Repeatedly iterate on a stated goal with data to find some answer that's hidden in the data, right? That is at some level what we're training students to do. If we can start building these looping auto GPTs with code execution and Wolfram completion, what should we be doing with teaching? And this is kind of the question of the talk. And my answer is I have no idea. And I'd love to turn this to a discussion with everyone as to what you think this means for teaching. Mel, take it away.
I'm dying a little bit. I'm devastated to hear you say that, like, the point of our teaching is to get people to solve data problems, because that's absolutely not the point of anything that we teach. So what we're teaching is we're teaching the critical evaluation, the insight, the knowledge of when the stuff that comes out is right or wrong, how we would frame that context, why is the context important, like the skill in this, like as great as this is, and that's cool, it really is no more than Stata or R or like, and if you don't know what you're doing, you are screwed. And the only way, especially when you start getting to higher level stuff, like this is cool, it can do regression, it can do logistic regression, but if we're going to get you to do hierarchical computational Bayesian analysis of like complex human behavior, and you've not ever learned how to even do this properly, and you've been relying on chats, how can you hope to have the skills and knowledge that you need to be able to deal with? And so, I mean, I can see how this is cool, and you could use this in place of like R or Stata or whatever it is that you're using, Julia. You could use this in place of all of that and ask people to like show them how to prompt and show them how to check, but that doesn't take away from like the most important part of what you're learning at university, which is like not the physical solving of the problem, but the becoming familiar with the structures and the concept, the meta stuff, right?
So I was going to take that theme and turn it into a question for Peter, which is, the only thing that was hard coded in your in Dr. Ramos was the prompts that you gave it there, right? Like the things that you fed in. And I was wondering if you want to how much of your pretty sophisticated undergraduate training and literacy with all these statistical concepts that you have, the knowledge that you need to be able to check the assumptions and how to interpret those plots. Things like how much of that do you feel like you brought to the task of defining this system, like asking, soliciting context, and how much engineering you put into the crafting the right prompts and things like, what's your reflection on how much of the sort of critical evaluation sort of techniques of
Good question.
and training that you have, how much of that did you bring to the task of Dr. Arnold? If that makes sense.
Yeah, well, I think from my perspective as a student that, like I'm a math student and I hate programming. Like this project involved a lot of software engineering and I absolutely hated it. And so, but I think it was for me worth spending a month learning how to use Python so that I don't have to use R for an hour to do the assignment. So this thing, like you do all these simple, you do all these simple things, but it still took my understanding as a mathematician to be able to interpret it. And I think that's what's more important for me, is to be able to use my math skills to do data science rather than relying on having to know the right code to do stuff.
Yeah. So how do you teach that then, right? Like how do you convey to your students such that we don't, even at PhD level, we can have this insight that actually the most valuable thing that you're learning throughout your degree is not the code, but the way that we think about it, the practice that we have, the depth of understanding. And how do you get that depth if everyone's using Dr. Ahmed's?
In fact, I think what you've produced is an opportunity for more volume specification and less understanding. So, and I think this is a real problem for all AI development, is that you're pointing it at the wrong thing. So if you can't improve someone's statistical thinking, you haven't improved anything. What you've made is something that will get someone to the wrong answer more quickly. So what you need to be thinking about is how could you use your tool to improve statistical thinking, which is why I asked you about misspecification. If you could produce a tool that would help people to better hone the questions that they ask of data so that they're not making incorrect inferences, you will have done something great for humanity. But what you're doing here is just taking people further away from that, and that's unfortunate. And I think maybe, if you've got if you're looking for someone to use your great skills and all of the knowledge that you have, point it at something that matters. And what matters at the moment is people drawing incorrect conclusions from their data, making causal inferences where they can't make them, specifying the models that they use. So using, a linear regression where it's a non-linear relationship, really basic stuff. If you could help to produce something that a human can use to improve their thinking, then that's something important. So use your MIT opportunity for that.
That'd be a good thing to chuck at the data, to chuck at the Dr. Arnold's, right?
Yeah, that's
Somebody's
right.
got a data set, where it is, we know it is. Where linear regression and logistic regression, the types of things that would naturally spit out. Aren't specified.
Well, I think it breaks in two key ways there. One is out of domain questions where the data's never been seen before, and it just breaks catastrophically. And the second is these AIs, what made the secret sauce that took it from 3 to 3.5, made it really good, is this reinforcement learning from human feedback, which is this particular task that says, whatever the human says, do that. Because these AIs are trained on these weird tasks of filling in words or completing sentences, and they kind of do whatever they want, whatever makes most sense to the AI. They're fine-tuned to do exactly what you said. And an immense amount of money is going into making AIs that do what you say. But that's not necessarily what we want in a data science context, right? You want something more exploratory, more reflective, more contextual. And that is why I think building something like Dr. Armand's is really good to frame around.
I like the way that you have to give it the context. It reminds me though of when I started my honours, I used Winbugs, and it used to have this thing on the very front page that said, warning, sometimes you will give this program data that it shouldn't be used on and it will fail and give you nothing. But worse, sometimes it won't fail and it will give you an answer that is completely unusable or wrong, or that something along those lines, and you won't know. So there's like a base level of like, you need to know what you're doing to be able to interpret whether this thing is reasonable or not to start with.
Causal inference is a good example of this, where if you tell it to perform a causal analysis, it's like a lot of assumptions are going to like causal reasoning, right? Where you need to like set up a preponderance of evidence and like build the right models. It'll build you some like statistical inference task, like a diff and diff or something. But it might be utterly nonsensical as like a boundary, right? Like it will just like do what you say, even if it's not the right thing.
Yeah. There's this wider context of teaching critical thinking, which we all want to do from high school on, but if you've ever looked into the literature, it's famously difficult to actually do. Anyone who thinks they're teaching it has to accept they're teaching it with indifferent success, because it sort of doesn't matter which of the many strategies people have thought of. When you actually measure increased ability for critical thinking, you often don't find it very much in the students. So I'm reminded we put in assignments where we try to teach critical thinking, and you'll ask for a confidence interval on a parameter that is only between 0 and 2 in the data, and students will have done something wrong and their confidence interval will be -15 to 360. And so, and they'll submit that in the assignment. And the reason they submit that in the assignment is not because they're stupid, they're very clever, but the code said -15 to 360. So in some ways, this is something, the weak point here is something we already fail many of our students. And so building in any kind of reflective capacity, even the AI going, would be neat.
What's this going to do for the ability to understand what the code's doing and then understand that the code's doing what you want it to be doing? Taking out actually writing the code and understanding what the function is doing. So is this going to completely destroy that? Because obviously once you've been trained, this is great, you know what's going on, you have the ability to critically think about what it's writing. What about new students coming through who are just like blindly using this because it seems to run?
So no idea how to, if we learned to code we all learned to code pre-ChatGPT, I have no idea how I would learn to code now, because I would just end up using it and it would new to my brain's ability to like generate authentic code. I think there might be just like a side plug, a role, if anyone wants to like look into this, of adversarial assignment generation with these tools, where like you play test different assignment questions against ChatGPT and see how well it can break, and you essentially just recursively iterate until you get a question that can't be done, that requires like a high level cognition as a way to make better assignment questions. Dylan.
Isn't this there's a few points here, I guess, going back to the critical thinking thing and critical evaluation stuff. There is that sense that, large language models can't do this perfectly, but that at its core is just a deeper contextual model, right? So with more context, there's API plugins for this that I've seen that, you give the data set and you're like, analyze the data, and it's written a full paper. Some of it hallucinates because it's still got some of the issues, but given like how quickly these things are evolving, and when you've got like even taking the human out of the human reinforcement learning side of it, and you've got large language model reinforcement learning that ends up being a cyclic thing, it can kind of start to improve that context. And I guess on data set, and it figures out the critical components, like there's a logistic regression wrong here, maybe it goes, I'm doing this in a frequentist setting, but a Bayesian setting, and it promotes ideas that maybe you don't know about necessarily at a student level, but it might promote that interest into maybe taking a different avenue, right?
One angle here, like the frequentist versus Bayes is a good example. For anyone who's like been like marking things with the Chegg examples, like people put a question on Chegg and someone will come and answer it. And they'll answer it using a completely nonsense, like some random method that exists on the internet that they learned. But it's not what you taught in your course. It's like a huge giveaway. They've used Chegg to cheat. And like I think in some sense you have a similar effect here.
Except for the thing that I'm struggling with all of this, and I was calling, the thing that I'm struggling with is that it gives an answer to everything with the utmost level of confidence, right? And so everything is presented as truth. If you have no experience or understanding, depth of, you can't tell the difference between the bits that have been hallucinated and the bits that are real, you know?
Yeah.
And so, I mean, I would love to see something that like provides some kind of like confidence on the statements that are provided, like which bits have been estimated, which bits have been averaged, which bits are they, is like directly taken from somewhere that they're like a, you know, I mean, that's never going to happen, I don't think.
Well,
Kind of no,
Not this week.
give him a month. We'll get him to it.
Want the students to bring that.
Yeah, but how do you get the students to do
I
that?
think this lends itself to the bigger problem with where, you know, the teaching and how we incorporate these things in, how new students will start to learn to code, right? It moves away from necessarily the standard way of thinking that we've all grown up with, and more towards this prompt engineering, this like prompts feature engineering idea where you still need to have a level of understanding to be able to drive this model forward, but the steps that it can take by itself might be leaps and bounds beyond what you can currently do. But if it can take you from point A to point A.5, maybe on a much quicker scale, then by the time you finish undergrad, you might be at like, you know, halfway through PhD level. And so there's like opportunity, well, naturally there's the two sides, you know, we might just end up with a lot of people who are really good at doing garbage. But I don't think we've yet seen how this could be used to generate anything.
So I think, I do think like it's going to be used, and like acknowledging that can online people, absolutely, Ben, you can ask questions.
No, kick him out of the series. Don't allow him to ask questions.
2 minutes.
Yeah, well, I mean, so I want to like put in a plug for two things. I do think we need to teach like contextual understanding and like critical thinking over the results of these things. But I do think shifting toward teaching that is better. And I think teaching the human component of what data science careers and jobs and PhDs are like. So my research, you know, full disclosure, is around distributed data. I think it'd be a fun assignment to give fragments of data to the entire student cohort and have them collectively come up with an insight of that data. Because that's more representative of like the actual problem task of being a data scientist, which is like talking to people, hunting data, finding solutions, finding things on impartial data sets, and doing the critical thinking there, instead of just the straightforward, here's a data set, here's a question, ask the question. And I think data science education is going to become really fun in the next 5-10 years, but unfortunately it's all of your jobs to make that fun and weird, and I'm really sorry that you're going to have to go through this. Ben's not going to question. We're running out of time.
Yeah, on that note,
Yeah.
maybe we'll wrap it up there. I mean, Toby, you're around for.
Yeah, I'm grabbing lunch with Mark, but I'll hang around here for a little bit, chat. I'll be around all afternoon.
Cool.
Woo!
Sorry,
Ben. Stop the share, stop the record.